In the 7th question, you have x minus 1 upon under root of x square minus 1. How will we handle this one? Okay, in the denominator you have a simple thing, but in the numerator you have a linear expression, right? So this is actually of the form linear upon root quadratic, or which is actually px plus q upon under root of ax square plus bx plus c form. And these type of integrals where you have the numerator and under root of quadratic in the denominator can be written as numerator has to be expressed in terms of derivative of the d by dx of denominator, derivative of denominator plus some constant term. Finding the values of a and b is the key over here. Now writing it in this particular form, or you can actually say we are writing L as that linear term as a times d by dx of that quadratic plus b. You can say this, or px plus q is written as a times derivative of this plus another constant b, right? Important thing is, if you can find a and b, this is always equal to this, this is always equal to this, this is always true. So this equivalent to this is actually an identity, right, which is true for all values of x. We can easily find a and b. Once we find a and b, we can separate that single integral as sum of two integrals, in terms of two integrals, right? And those two integrals will be easily solvable. How? This becomes pretty easy. Okay, you have the quadratic in the denominator and you have the derivative of the quadratic in the numerator. So quadratic can be substituted as t and easily solved. In the second, you will have simply quadratic in the denominator, and thus can be solved with standard formulae, right? Standard formulae. So we'll use that idea. I is equal to integral of x minus 1 upon under root of x square minus 1 dx. Okay, this is the denominator, this is a quadratic in the denominator, this is a numerator. So let x minus 1, we'll use the form x minus 1 is equal to a times derivative of this x square minus 1 plus some other constant b. This tells me, okay, x minus 1 is always equal to a times, this is 2x plus b, is it not? Yes, please observe this. Okay, and since this is always equal to this, compare, simply compare coefficients of x and constant term. Compare coefficient of x and the constant term. Therefore, coefficient of x is 2a and here it is 1. 1 is equal to 2a. Minus 1, the constant term is equal to b. Right or not? So that tells me a is equal to 1 by 2 and this tells me b equals minus 1. Okay. Once you find the values of a and b, that's one part of the solution. That's one part of solution and you have used this idea to write it as this, right? Let me get rid of this thing and then we'll continue further. The next step says that we can substitute these values over here. Therefore, I is equal to integral of x minus 1 has been written as a times 2x. A is half. Half times 2x. Okay. Plus b, which is minus 1 upon this under root of x square minus 1 dx. These will be written separately, 1 by 2 integral 2x upon under root of x square minus 1 dx minus integral of 1 upon under root x square minus 1 dx. This can be solved with a simple substitution now. This part over here, let x square minus 1 is equal to t, which tells me, okay, 2x dx is equal to dt. We have planned it in such a manner that the derivative of the denominator comes in the numerator. And this here is a standard formula. What is that? 1 upon x square minus a square in the under root is equal to log mod x plus under root of x square minus a square. That's simple thing, right? So using this substitution, this becomes 1 by 2 integral of 2x dx is dt upon under root of t plus, this here is simple. Okay, this is not a plus, this is a minus over here. Minus, this is log modulus, you can write that directly, right? X square minus a square, x plus under root of x square minus a square modulus. Okay, and this integral is remaining. After that, we'll add that constant of integration. This 1 by 2 is simple. This is t power minus 1 by 2. Okay, and what is that equal to? T power 1 by 2 upon 1 by 2. That becomes 2. That becomes, okay, from the denominator, if you have 1 by 2, that will come in the numerator. This becomes 2. And t power 1 by 2 in the numerator. Okay, minus, this is log modulus of x plus under root of x square minus 1 and plus a constant of integration. Now, this 1 by 2 and 2 gets cancelled. T under root of t is actually under root of x square minus 1. That comes over here, minus log modulus x plus under root of x square minus 1 plus constant is the final answer for this complete question, as you can see. That's the final answer. Yes. That's all that you have in this 7th question.